So what I'm going to do is I'm going to light my wood flint on fire, have a flame going. With one hand, I'm going to stick my thumb up under the test tube with the negative label on it, whip it over, and then I'm going to stick the flint in, the wood flint in, right after I move my thumb. So that's my plan. Let's see if it works. So I'm going to light the match, hopefully. There we go. So I'm going to light the wood flint. Drop that in that water. So while I have my wood flint going, I'm going to try to put my thumb over the... Okay, got it. Bam! That pop is a positive test. Let me douse that. That pop is a positive test for hydrogen. So my conclusion is that the test tube connected to the negative terminal of the battery has hydrogen in it. Pretty amazing. Okay, I'm just going to set that right there. I'm just going to take the other, it's still an exciting test. I'm going to take the other dry end of this flint, and for the auction test, with the auction test in here, you don't have a flame, you just have a lit ember. You stick the lit ember inside of the test tube, just like I did before. I'm going to invert it, and you see what happens. So let me light a match again. I'm going to take the dry end of this wood flint, create a flame. I'm going to keep the flame going, but I'm going to blow it out before I do the test. Thumb over the mouth, whip it over, burning ember. You see it relight? Gets bright. So that is kind of cool too. That's a positive test for auction. Auction will relight a burning ember. I'm going to put that out carefully. And that is our lab for this one. See you in the next video. Okay, let me just state the basics. Evidently, a 9-volt battery which produces electricity when run through water produces gases. There's one gas that's produced at the negative electrode of the battery, and there's one gas produced at the positive electrode at the battery. These are the facts based on our observations as we see them. So what can we conclude from these observations? What meaning can we make? Well, we know what the hydrogen test is, and we know what the auction test is. They were established as chemical tests at the time these experiments were done. So back then, if scientists were running these tests, they, like us, can confirm that the gas produced at the positive electrode, the test tube connected to the positive terminal of the battery, is in fact oxygen, and the gas collected at in the test tube connected to the negative terminal of the battery is in fact hydrogen. These are things we can say for sure. And on top of that, we can also say, evidently, when you run energy into water, out comes oxygen and hydrogen. And maybe in the 21st century, this is kind of expected. Many of you probably know that the chemical formula of water is H2O, H is the hydrogen, O is the oxygen. So evidently, we broke apart water into its constituent elements. This is no small conclusion. So just to take a step back for a second, I mean, what we did was walk in the footsteps, literally walk in the footsteps of Humphrey Davy, who was the one to do this for the first time. He was using this new thing called a battery. At the time, it was called a voltaic pile, which could produce a continuous flow, a continuous current of electricity. So this was an amazing thing in the early 1800s to have access to and to be able to use. And so what Humphrey Davy did is what we did, and he was able to see that two gases, two elements, were able to be sort of separated out of liquid water. Another cool thing to kind of keep in context is that up until this time in history, water was just assumed to be a pure thing. I mean, given its symbolic importance in many cultures and religions. In fact, it's named in it's referred to in the second sentence of the Judeo-Christian Bible. The Greeks had believed there was 4 fundamental elements that made up the entire universe: earth, air, fire, and water. This was, an alarming idea that this pure, symbolic, esteemed material was actually just a composite of 2 other things. And so this was a pretty big finding in the early 1800s. So one anecdote in the history of science that I love to share is this experiment conducted by Van Helmont in the 1640s. So this is super early. And it's actually one of the first sort of experiments in chemistry where measurements were actually taken. So it was one of the first systematic chemistry experiments recorded. So what he did is he planted a small willow tree in a big pot of soil. He weighed the soil, he weighed the willow tree, and just watered it every day for 5 years. So already it sounds like a pretty intensive experiment that took a lot of discipline. But anyways, that's what he did. It was awesome. And after 5 years, he uprooted the tree, and he found that it had gained 164 pounds. So of leaves, bark, roots, it just grew. He found that the mass of the soil did not change appreciably. So his conclusion was clearly, if water was the only thing added to the system, that trees must be made of water. There was no other mass coming into the system. And interestingly, this is 150 years before Lavoisier sort of confirmed this idea of the conservation of mass. So Van Helmont was implicitly knew of, or was aware or believed in this idea of the conservation of mass. Anyways, his conclusion was there are not 4 elements like the Greeks claim. There's actually 1 element. So all of matter in the universe is made up of water, and I'm water, you're water, the earth is water, and they're all just different forms of this 1 element, and evidently trees are made of water too. So obviously we know now there's a catch here. Curious if you could kind of figure out what this catch might be. What was Van Helmont not aware of with regard to how trees grow?